Hello everyone, myself Nagendra Verma. Today we are going to discuss Fibonacci search method in Java. So let us start our discussion. So let us look at the introduction of this Fibonacci search method. The Fibonacci search method is a search algorithm that finds the minimum or maximum of a unimodal function by narrowing down the search interval using the Fibonacci sequence. So before going into the process, let us look at what does this unimodal function mean. So this unimodal function is a mathematical function that has a single maximum value or a single minimum value within a certain range. So before applying this Fibonacci search method to a function, we need to ensure that the function we took is a unimodal function in the range which we are evaluating. So now let us look at this Fibonacci series. So this series is used to narrow down the search interval. So this sequence is a series of numbers in which each number is the sum of the two preceding numbers starting from 0 and 1. So in the search method, we use this series for reducing the length of the interval as we discussed before. So this series goes as 0, 1, 1, 2, 3, 5, 8, 13, and it continues. So now let us look at the process of this Fibonacci search method. So by initially we start setting this lower bound and upper bound as a and b. Now we compute the length as this upper bound minus lower bound, which is equals to b minus c. Now we compute this L star. This is used to evaluate the two new points in the range. So this L star is given by f of n minus k minus 2 by f of n into length. So where this f of n minus k minus 2 indicates the number in the series. So this n is the number of iterations, this k is the iteration number, the current iteration number. Now using this L star, we calculate the two new points p1 and p2 using the following equations. The first point was calculated as a plus L star and the second point was calculated as b minus L star. Now we compute the value of the function at these two new points that we got before. Now, by using the unimodal principle, we reduce the search interval. So, if the aim is to minimize our function and f of x1 was greater than f of x2, then we eliminate the left part and make our new interval as x1 comma b. If f of x1 was less than f of x2, then we make our interval as a comma x2. Now let us look at the maximization of a function. Now if our aim is to maximize our function and f of x1 was greater than f of x2, then we make our new interval as a comma x1. If f of x1 was less than f of x2, then we make our interval as b comma x2. So we repeat this process until the value of k reaches to n. So at every iteration, we increase the value of k and we repeat this process till the value of k becomes n. So now let us look at the generation of Fibonacci sequence, which is important in reducing the search interval. So this Fibonacci search sequence can be stored in an array list in the case of Java. So we use this array list of type double and named it as sequence to store this Fibonacci sequence. So initially we added 1 and 1 to the array list. Now until the number of numbers in the sequence reaches n, we calculated this. So we calculated our new value at every iteration as sequence dot get I minus 1, which gives the previous number, plus sequence dot get I minus 2, which gives the previous number to the number before. So in this we calculated the new value and added to the array list and added to the end of the array list. So in this way we calculated the n numbers of the Fibonacci sequence. So now let us look at the function interface which we use in Java. This helps a lot in Fibonacci search method. So in general, we write functions in Java using this function interface. So let us take an example that we want to write x square plus 54 by x in Java using this function interface. So we write this as function double comma double. This initial double indicates the type of the variable, and this double indicates the type of the output which we get. So both are double. So now we want to write this x square plus 54 by x. So we use this lambda function to write the function in the function interface. So this was a square plus 54 by a. So which was the function which we need to write. So what does this function to apply do is, so this gives the value of the function at the point which we need to get. So now let us look at the search method code. So this Fibonacci search minimum takes input arguments as this function interface f, the double value A, double value B, that are the upper bound and lower bound, and the number of iterations. So initially we start our iteration as k equals to 1. Initially we set k equals to 1, the iteration number is 1, and we repeat this until the k equals to n, as we discussed in the presentation. So we use a while loop to ensure that. So initially we need to calculate the length of the interval, so which is equals to b minus a. Now we calculate this L star, as we discussed, sequence dot get n minus 2. This is the number in the sequence. So we have store all those Fibonacci sequence array list. So we are getting from sequence by using this get method. We are getting the n minus 2 method number, and this is sequence dot get n, the last number, into length, which gives the L star. Now we need to calculate the 2 points in the range. So this was calculated using a plus ll, and the point 2 will be calculated as b minus l. Now we apply this to the function to get the value of the function at those points. So we stored value 1 for point 1. So we calculated the value of the function at point 1 and stored in value 2. Similarly, we calculated the value of the function at point 2 and stored it in value 2. As our aim is to minimize the function, if value 1 greater than equals to value 2, we make our a as point 1. In the opposite case, we make our b as 0.2. So at every iteration we need to increase the value of the k. So we need to repeat this process until k equals to n. So now we will print out the final range. So this was the final range, the a and b. Now let us look at the maximum. In the case of maximum, so the process is almost same, but when value 1 greater than value 2, we need to make our b as point 1, which is opposite to the minimum case, and a as point 2, and value 2 was greater than value 2. Remaining thing is same. Now let us look at a typical example. Let's look at this a square plus 10a. This is how we write the function in Java interface. Using this interface, we need to calculate the value of a square plus 10a, the maximum value of a square plus 10a, in the range minus 5 to 15. So we generally know that the value will be at 15. The maximum value will be at 15. So let us try with 10 iterations. So let us look at the range for 10 iterations. We are getting 14.99, 15. Obviously, the range, this will be the range where we have maximum value. So if I increase the number of iterations, our range should be much more accurate compared to the previous one. So yes, we are getting much more accurate range compared to the previous one. As we increase the number of iterations, we'll get much more accurate range. So now let us look at the number of, the applications of this Fibonacci search method. So this was widely used in financial analysis to identify the support and resistance levels, which was widely used in this technical analysis of stock market. This is also used in robotics to optimize the motion planning of robots. So it can be used to determine the optical path between these 2 points in a given environment. So now this was also widely used in database management system, where we used to find some things in this database management system using this Fibonacci search method, as this gives a very good time complexity, which is of login, which is very faster than linear search. So this was also used in this computer science. So thank you.